Lesson 15.2, Task 2. Explore basic trigonometric functions for special angles. In the previous task, you defined the coordinate xy for the point on the unit circle where the radius intersects it at x equals cosine of theta and y equals sine of theta, based on your observations of special triangles in the first quadrant. Alright, so as you remember, so the x and the y, so this is going to be defined as your cosine, and this value is defined as your sine. So that means the x and the y are defined as x equals cosine of theta, y equals sine of theta. Now you use reflections to explore trigonometric functions of angles that have a terminal side in quadrants 2, 3, and 4. Alright, so if we're looking at a 45, 45, 90 triangle, remember in the previous task, we found that with a radius of 1, because this is a unit circle, 1 unit, then your side lengths are square root of 2 over 2 and square root of 2 over 2. Alright, so now we're going to look at what those same angles would be in the different quadrants. So remember, when we're looking at different quadrants, this is your positive x and this is your positive y. So both of these are positive and positive. When you go to the left of the origin, this is going to be a negative and this is going to be up, so it's positive. So you're going to have a negative x and a positive y. In the third quadrant, you go left, which is negative, and down, which is negative. So in this quadrant, all your angles are going to be negative, negative. So that means your cosine and your sine will both be negative in the third quadrant. And in the fourth quadrant, you go positive on the x and down, so negative on the y. So you go positive and negative. So any of the angles in the first quadrant will be positive, positive. Second quadrant will be negative cosine, positive sine value. And in the third quadrant, they'll both be negative. And all the angles in the fourth quadrant will be positive and negative. So that's just kind of good to know. Alright, so it says a 45, 45, 90 triangle is inscribed in a unit circle in the first quadrant with one leg along the x-axis. The angle is then reflected into each of the other three quadrants as shown. What are the coordinates of each of the points labeled A, B, C? Alright, so we're going to get that information from here. This is still a 45, 45, 90 triangle. It's just in quadrant 2. So it's going to be the same numbers, maybe a different sign. So I'm going to have a negative and a positive. So it's going to be negative, positive. So that eliminates the last one there. Alright, in B it's going to be left and down, which is negative, negative. So it has to be the first one. And then in this one it's going to be positive, negative. So positive, negative would be the one that works. So basically we're just looking at the sign based on which quadrant we were in. How could these coordinates be used to find sine, cosine, and tangent of the reflected angles in quadrants 2, 3, and 4? So because cosine is your x and sine is your y on the unit circle, you can use the coordinates to find the values of those trig functions. The tangent of theta is the ratio of the side opposite theta and the side adjacent theta. So opposite over adjacent. What is the value of the angle of rotation theta in a counterclockwise direction? Counterclockwise, remember, goes through the quadrants 1, 2, 3, 4. With a terminal side that passes through point A. Explain how you know. So it says, what is the value of the angle of rotation in a counterclockwise direction that passes through point A? All right, point A is here. So I know that I have 90 degrees plus another 45, or you could do 180 minus 45, because you know what a semicircle is always going to be 180. But if you know that each quadrant is 90 degrees, and you know this is a 45, 45, 90, all you have to do is 90 plus 45. All right. Now find the values of theta for the angles of rotation in counterclockwise direction for the terminal sides passing through points B and passing through points C. All right, so if we go back up here and look, all right, point B would be 180 plus 45. So we're going to have 225. And then angle C was in the fourth quadrant, so we could do 360 minus 45, and that would be 315. All right. So again, you could do 270 plus 45, or you could do 360 minus the 45. All right, for a 30, 60, 90 triangle inscribed in the unit circle, for theta 30, reflect the triangle into each of the other three quadrants. What are the coordinates of the points of intersection? All right, so again, we're just looking at the sine value. You can see we've got square root of 3 over 2, and we've got 1/2. So the difference is, what does it matter in quadrants 2, 3, and 4? So quadrant 2, remember quadrant 2 goes left, which is negative, up, which is positive. So it's going to be negative, positive, which is this one. Quadrant 3 is left and down, so negative, negative. And quadrant 4 is positive, negative. All right, so use these coordinates to find the sine, cosine, and tangent of the reflected angles in quadrants 2, 3, and 4. All right, so very quickly, we are going to plug this in. So we're looking at okay, so we're looking at a 30, 60, 90 triangle. So for a 30, 60, 90 triangle, we know our side lengths are 1/2 and square root of 3 over 2. So remember, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So if we look at our ordered pairs, we know this is cosine and sine. So we know our cosine is going to be some version of square root of 3 over 2. When I say some version, I mean positive or negative. And our sine is going to be some version of 1/2, positive or negative. So we just have to figure out whether it's positive or negative. So in the second quadrant, the sine goes up, so it's positive. In the third quadrant, it goes down, so it's negative. In the fourth quadrant, the sine goes down, so it is negative. All right, so the cosine in the second quadrant goes left, which is negative, so it's going to be negative square root of 3 over 2. In the third quadrant, it goes left and down, so negative square root of 3 over 2. And in the fourth quadrant, it's going to be square root of 3 over 2, because the cosine goes to the right of the 0. All right, tangent is going to be opposite over adjacent. So tangent here, we're going to have a negative square root of 3 over 3. And I can look at the signs here. Basically, a positive times a negative is a negative. Negative, negative becomes a positive. So I'm going to have a positive square root of 3 over 3. And then I'm going to have a negative. And that should be correct. All right. All right, replace part C with a 6. We got a 30, 60, 90, but this time we're looking at angle 60. So theta is our angle, so we're looking at angle 60. All right, so again, we're just looking at the signs. These have switched from the 30, 60, because now it's a 60, 30. But we still have the same numbers. We're just looking in quadrant 2. What are the signs? Again, left is negative, positive. So then I'm going to go negative, then positive. Quadrant 3 is negative, negative. Quadrant 4 is positive, negative. All right, same thing, just we have reversed it from the 30, 60. Now we're looking at the 60, 30. So we're going to have square root of 3 over 2. Quadrant 2, remember the sine is our y value, so it goes up. Quadrant 3 goes down, quadrant 4 goes down. So we need negative square root of 3 over 2 for each of those. And then our cosine is our x value. So in the second quadrant, x goes to the left, so it's going to be negative. In the third quadrant, the cosine goes left, it's going to be negative. And in the fourth quadrant, it goes to the right, so it's positive. All right, tangent again is opposite over adjacent. Okay, I'm going to just look at one divided by the other. And then the sine is basically what I need. So I know it's going to be square root of 3, but is it going to be positive or negative? Positive times a negative is a negative square root of 3. Negative negative makes it positive. And a negative positive makes it negative. All right, so it says identify the counterclockwise angle of rotation that results in the terminal side of the angle passing through the points identified in parts C and D. Select all that apply. So when the angle is 30, so we're talking about what the angle of rotation is. When the angle is 30 for our each side in each quadrant, it's going to be 30, it would be 90 plus 60, which would be 150, so it would be this one. And then for our 60-degree angle, it would be, remember each quadrant is 90 degrees. And if we're going to do 90 degrees, our 60-degree angle is only 30 from 90. But it would be 60 from 180. So you either do 180 minus 60 or 90 plus 30. So 90 plus 30 would be 120. So we know it's going to be this one. All right, and again, you could just look at those rotations and see how that works. All right, so your sine for each quadrant. We looked at this kind of at the beginning. You're going to have a plus, plus, plus for tangent because it's sine divided by cosine. And then quadrant 2, the sine is your vertical, so it goes up. Cosine is to the left, it goes down. And then a positive and a negative make that negative. Quadrant 3, negative, negative. Cosine goes left, and this goes, cosine goes left, sine goes down. So it becomes positive. And we've got a positive negative, which gives us negative again for that one. All right. What do you notice about the signs of the values of sine, cosine, and tangent in each of the 4 quadrants? Use the coordinates of the points you identified in parts A, C, and D to justify the information shown in the table. In the first quadrant, sine and cosine are positive because x and y are positive. This means tangent is also positive. In the second quadrant, the sine is positive because cosine is negative. Sine is positive, but cosine is negative. This is because y is positive, y goes up, it's your vertical, and x is negative because it goes to the left. Tangent is negative in the second quadrant. In the third quadrant, sine and cosine are both negative because both x and y are negative. Tangent is positive because a negative divided by negative is a positive number. In the fourth quadrant, sine is negative and cosine is positive. This is because y is negative and x is positive. Tangent is a negative and a positive is a negative. All right, so that is just putting into words basically what is in this table here. All right, that is all for task 2. If you have any questions, let me know. Real quick, I'm going to show you this. Basically what we've done is just talk about these 3 angles in all 4 quadrants. And this is going to be somewhere in your notes for you to look at. But this is the different angle measures in each of the 4 quadrants that we have just talked about. All right, that's all for task 2.